Welcome back to my channel. Let us learn some more problems of periodic properties and elements, class 11. So we have a table with the boron having ionization energy of 801 and aluminium 577, and then we have gallium 579 and indium 558 and tellurium with 589. Now these are the values of the delta IH1 values, that is ionization enthalpies. Now the question is, why is there a deviation of a higher value, that is from 801 to 577? So for this we have to understand the periodic arrangement of boron and aluminium, and also the some of the factors such as size of the atom. So let's go on with boron. So we know boron is a very small atom, and when you observe, as you're going from left to right, the size of the atom goes on increasing. So boron is a very small atom because it has less number of electrons, so hence we can expect a very high value of ionization enthalpy, because smaller atoms have very strong nuclear charge. So when the nuclear charge is extremely strong, the electrons are very difficult to be removed from the outer shells. Now moving on to aluminium. So we know aluminium is a very large atom compared to boron. So when you talk about larger atom, it also means that nuclear charge is smaller. So when nuclear charge is smaller, then we electron doesn't energy required for the electron to be knocked out will be lesser. That's why ionization energy of a- aluminium is 577 and that of boron is 801. Now the same understanding we can have with gallium also. With gallium, we have one more concept called as the shielding effect. Now, what is meant by shielding effect? It's very clear that, let's say this is the, so let's say this is the atom of gallium. These are called as the inner orbits, and these are the, okay, now these two are the inner orbits. Let's say 1s and 2s are the inner orbits. Now shielding effect works when the number of electrons, number of orbits are very high, and all the electrons residing in the inner shell, they start shielding the nucleus. Okay, means there wouldn't be any addition, or if there's any addition of the electron to the outer orbit, it will be very difficult because these inner orbits are already shielding the nucleus. As a result, the nuclear charge will be very less. So when the nuclear charge is less, again another expected value of ionization energy can be like this, around 579. Okay, so mainly explaining the deviation from these values, it would be, one of them is larger atomic size, and second would be the shielding effect, wherein the inner orbits are shielding the nucleus, and because of this the outer electrons can be easily removed easily. So that's why the value of the ionization value of gallium and aluminium and indium and tellurium also, they are similar range, whereas that of boron is very very high. Okay, so this is one of the explanation. Now let's go on with another example. So there's a comparison. Okay, so which of the following will be having a higher electron gain enthalpy? So first one, comparison between fluorine or chlorine. So let us understand the atom of fluorine and chlorine. So fluorine and chlorine both belong to the group 17, and this is how they are placed. Fluorine is smaller atom compared to chlorine. Now as we go down the group, it is we know that the atomic size increases. So chlorine will be having a higher atomic size compared to fluorine. But here let us also understand the electronic configuration of fluorine and chlorine. So fluorine atomic number is 9. So if you write the configuration, 1s2, 2s2, and 2p, 5. So here the outer orbit is 2p. Okay, so 2p is a smaller orbital, right? And if there are any incoming electrons getting added to the shell, there will be high repulsion. So this is one disadvantage, or you can say this as an instability in fluorine, because 2p is a smaller orbital, and the electrons getting accommodated in it will be experiencing more repulsion. Okay, so as a result of which the electron gain enthalpy of fluorine will be less, around minus 228 kilojoule per mole. But when you compare it with chlorine, so let's understand chlorine now. Chlorine atomic number is 17. And when you go on to write the electronic configuration, at the outer electron, that is, I'll just write the outer electron, it will be 3p, 5. So now when you compare the orbit, second shell and third shell, obviously third shell is larger in size compared to that of second shell. And here, accommodation of electrons in 3p orbital will be less cumbersome, and it will not lead to more repulsion. There will be a smooth transition or smooth movement of electrons into the orbit. So as a result of which, chlorine will be more stable, and it will be having higher electron gain enthalpy. Okay, so the higher electron gain enthalpy of chlorine will be is minus 349, and that of fluorine is minus 328. Okay, so that's one example. Similarly, we have one more example, that is comparing oxygen and fluorine. Now let's say oxygen and fluorine. Second example, oxygen, fluorine. Now when we look at oxygen and fluorine, this is how it's arranged in the periodic table. So it's very clear that both of them belong to the second period, and we know that fluorine is the most electronegative species in the entire periodic table, and oxygen is lesser electronegative compared to fluorine. Now when we look at the size of the atom, as we move from left to right, the size of the atom goes on decreasing, because nuclear charge goes on increasing as we move from left to right of the periodic table. So in that context, fluorine will be having a smaller atomic size compared to oxygen. Okay, now if I add an electron to fluorine, what happens is it becomes F minus. So fluorine has 9 electrons, and to this if I add 1, it becomes total of 10, right? Now 10 electrons is associated to the stable electronic configuration of neon. Now because F minus is stable, hence the energy released will be higher, because noble gas or inert elements are always having stability, because their energy released or the liberation of energy is always higher. So they are very stable, they don't compete with or they don't participate with any other electron bond formation. Now because F minus gains the nearest inert gas configuration, that is the electron with element with electron 10, so F minus will be having a higher stability, more stable, and it will be having more negative electron gain enthalpy. Okay, but on the other hand, if I take oxygen and if I add one electron to it, so oxygen has 8 electrons to this 9, so 9 is not nearing to the, or it is not reaching the stable octet configuration, and hence it does not gain stable inert gas configuration, and it will be having less electron gain enthalpy. Okay, fluorine will be having higher gain electron gain enthalpy, oxygen will be having lesser electron gain enthalpy. Okay, so this is the answer. So if there is any question based on this comparison, then we must be able to write the proper evidence. Okay, fine. Thank you so much for listening.